Briefly, I'm Nate Price. You just saw me over there, mostly. I am a software developer at Task Force Tips. I've been software developer for 2 years, CMC machinist before that, so a lot of experience in manufacturing space. I represent Task Force Tips on the MTConnect tag, been a member since the first MC² Conference in 2011, I think it was. My email address, nate.price@tft.com, if anyone ever has any questions. Task Force Tips, company I work for. We manufacture firefighting equipment like you see here. And we're focused on high-tech manufacturing, so we've been involved in MTConnect because, well, that's as cutting edge as it gets. And it's been 5 years of using it. So I will go right into the architecture of MTConnect now. What I'm going to be talking about is just a very basic overview of the architecture of a typical MTConnect installation. So at its most simplified, down-to-earth level, we have a device, which could be a machine tool, sensor, robot, bar feeder, a server that's presenting some sort of data, pretty much anything. Then we have an adapter. The adapter pulls information from the device, and that adapter's entire purpose is to convert. From that point, we have an agent, which pulls data from the adapter. And finally, pulling data from the agent is a client of some kind, which could be just about anything that would be interested in the data coming out of an agent. The important thing in this is you're seeing this one-way chain here, and that is by design. The data is intended to flow one direction, and this provides simplicity, and it provides security by design. So let's break down those boxes. Devices, I just told you, it's machine tools, it's peripherals, bar feeders, robots, sensors, conveyors, anything you want that you'd possibly be collecting data from can be a device. And finally, servers, and I can give an example of that later. The important thing to remember is that when we're talking at the device level, they're all talking their own language, and that's totally okay. That's the whole reason MTConnect is here, is so that we can work with all these devices that talk their own language. So then we bring adapters into the chain. And adapters are meant to be device-specific and speak the language of the devices they're written for. And there's all kinds of ways they can connect. They can do a hardware connection with DIOs. We said a lot on legacy machine tools, or say if you're connecting to sensors or something like that, you're going to have hardware connection to your adapter. We see software, and when we're into software, it can be all kinds of different software connections, anywhere from your native architecture machine tools. You're going to have an adapter that just runs resident on the control alongside the control software. We've seen other instances. We have other instances where we have a software adapter, but it's actually connected to the device over Ethernet and running on a completely separate device. So there's a lot of places adapters can get to, and the key there is that they have to be communicating with the device in some way to convert the data into something that is friendly to an agent, so that an agent can turn it into MTConnect spec. So what's typical with the reference agent is this SHDR protocol, which is transmitted over TCP/IP sockets, and it is nice and simple. And because of the way it communicates, adapters are actually remarkably easy to test with Telnet. I don't have to explain that because that'll get explained in the next presentation. So adapter behavior is, for example, we would have a device, we'd have an API command that interacts with that device. And so the adapter would be pulling data through this function. It would then translate the result of this function and output it in that shutter format to the agent. And it's just a simple pipe delimited format. Device is optional. In one of our instances, in our instance that I pulled this string from, we have a device because we have an adapter that's actually defining data for 26 different machines. So the device is kind of important in that instance. But it's just device, timestamp, date item value. Nice and simple, lightweight. You can run that thing from a tiny little microcontroller that has barely any RAM and no processing power whatsoever. So it's flexible. We can put adapters on just about anything. Agents are the one place of this chain where behavior is defined by the standard in all of the things that it does. And its purpose is to map what's coming from the adapters into this wonderful semantic model we've spent so much time developing. And its purpose in mapping this is to actually load up a circular buffer with data from these adapters. That's for fault tolerance and to make sure we don't miss anything when we're pulling data from the agent. And when we're talking in terms of connecting to an MTConnect device, this is the visible component that we're looking for. We're not really, once this whole chain is set up with your adapters and your devices and everything else, what you're looking for is the agents. So the agent's role in the chain, obviously they're pulling input from the adapter, like I said. Then they map the data items. I'm basically repeating the last slide on that. And then they respond to the 4 verbs to provide data to a client, the 4 verbs being probe, sample, current, and asset. Probe is the device model definition. Current is every data item in that device model, so that's exact moment in time. Sample gives you whatever's in the buffer from whenever you say you want to see the data, and is the heart of any streaming collection from the agent. And then asset deals in all kinds of different assets. Tooling is the primary one right now. So with the MTConnect reference agent that's on the MTConnect GitHub site, devices.xml is the file that lays out that device model. When you do a probe command, you're getting the devices.xml file directly. And the agent.config file its purpose is to point to all the different adapters that you might be connected to with the agent. So now we're on to clients. And the job of the clients, all the clients, is to query the agents and collect the data. And then from there, really the behavior they can exhibit from that point is wide open. We don't have any standards on that. For the most part, their job is to collect that data, run rules, run analysis, and give reports and all that fun stuff. And in a lot of cases, store the data. What's important in that is that it's not the agent's job to store data. It's the agent's job to buffer data pretty much just long enough to have fault tolerance. So if you drop your connection to the agent, you reconnect a minute later, you can catch up and you didn't miss anything. The actual job of storing data is not on the agent, it's on your client applications. And anytime you're going to have a user interface to actually view interesting things with your data, that is also going to be the responsibility of the client applications, not the agent. The best thing you're going to get from the agent is that formatted XSLT that you've seen and will probably see today. So I'm just going to jump right into example architectures, and we're going to start out nice and simple. Here we have 3 lovely machine tools. And on these machine tools, we have adapters and agents running on them. And so in this architecture, it's remarkably simple. Consider the lines Ethernet connections. We just point a client to these 3 machine tools, and we're collecting data from the machine tools. Nice and simple. So let's say we don't want to run the agents on the machine tools themselves. That's also an option. So maybe let's have the adapters on the devices, and we'll pipe all the content into a single agent. You could also pipe the content into separate agents that are running on separate servers, virtual machines, Raspberry Pis. It doesn't really matter, as long as it's something that has enough strength to run an agent. In this case, the adapters are still on the devices. The agent is configured to look to those devices for adapters, and then the client connects to the agent, and we have a successful architecture. So I'll jump right into something more specific, which is ours, kind of showing how much mixing and matching we can do. At TFT, we have a single agent, and we have, I think, 26 devices. It's somewhere in the high 20s. And we have adapters pretty much all over the place, depending on what the machine is. So let's start with 2 lovely CNC devices and a server with an agent. Some of the devices go straight to the agent. The adapter's on the device. We're ready to go. Some of them have black boxes that are adapters that are inside the cabin of the device. So for the purpose of this diagram, where I don't have a lot of space, that's the same scenario. Some of our machines have Ethernet-based adapters, and so the adapters reside on the server alongside the agent. They still are separate adapters, even though they're on the same server, because we're maintaining that architecture so we can plug all these different pieces together and get this mix and match. And then what we did, and what we've seen a lot of people do, is we wanted to supplement the data stream with things the machines didn't know, which is the operator currently running the machine, the part number, the operation number, if the machine's in setup or if it's down for whatever reason. These are all things that our operators know, that our operators are inputting into a client application they have. And so our MES is managing all that. And so we put an adapter on the server that pulls that data from our MES and converts it again into something the agent can understand. And so it supplements the data for every device in the agent's collection from that single adapter that's connected to the MES.
What's MES?
Manufacturing Execution System.
What is that?
It manages scheduling your operations as far as
Software.
It is a software thing, but ours is custom. So
Software, user interface, people.
Yes, yeah, user interface, the job schedule, all that stuff. That's your typical MES package. Ours is custom, but same function.
That's connected to the adapter?
Yes. So I have an adapter that is looking at the data from the MES and feeding that into the agent to, again, to carry operator information, what job's running, when we have operators report part counts so we can see what they're reporting for scrap. And then we're also looking when a machine is in downtime, we can have the operators say, okay, we don't have any material, or there's nobody actually here to run this machine, et cetera, et cetera. That all gets piped through that adapter into the data stream, so that when we're collecting in our client application, it's all aggregated inside of that agent. And so this is an example of a more complex architecture that is totally supported by this architecture that's set out as a reference for how to do MTConnect. Again, the agent is the only part of this whole setup that is defined in the standard. Everything else is us making everything work to feed data into the agent to get us good data out. And finally, the last thing I want to talk about briefly is peripheral connections. This is another one that we'll go into more detail in later presentations. But this is the one place where you look at what I was talking about, where everything is one direction, and you say, so if I want to have a bar feeder and a machine, or a robot and a machine talking to each other, how can I possibly do that if all they can do is read? So we have a basic chain set up on each side here. We've got a CNC with an adapter and an agent. We've got a robot with an adapter and an agent. That agent could actually be the same agent. It doesn't really matter. But in this case, we're talking about two discrete architectures. So from this point here, we really don't have any communication between the two. The CNC is outputting its stuff, the robot's outputting its stuff, and that's it. But if we have a client application on the robot, or if the robot itself acts as a client which can consume MTConnect, it can connect to the agent. And it can then monitor certain data items which are defined in how to connect robots or bar feeders that the CNC is outputting and act accordingly. And then it updates its data items, which the CNC would be mirroring that architecture. And so the CNC would have a client on board that could consume MTConnect output from the robot. And so we have, even though there's nothing actually opening connections and pushing data across through a read and read architecture, we can still facilitate integration between peripherals with devices. And that is the entire presentation, because that's how simple architecture is on this high level. So does anyone have any questions?
So could you elaborate a little bit more on the clients? Like, are clients like a web server? Is a client a specific software that you have running on your computer that reads from, like, yeah?
A client can be just about anything that is connecting to an MTConnect agent and pulling data. When I developed a library to connect to an agent and pull data, the first test I did was running it as a console application. That's still a client app. It wasn't doing much useful, but it was still a client. That's how simple a client could be. On the other end of the spectrum, there are several client applications that run as software in a service, where there's these cloud web server applications that have architecture behind them, collecting the data and processing the data, running rules, and then presenting this lovely web-based front end to the users. That's also a client application. So it really runs that entire spectrum You can have something incredibly simple and you could have something incredibly complicated, and depending on the application you're trying to address, if you have a client application running on a machine tool to facilitate the read-read, that application's entire purpose is going to be watching the peripheral it's connected to and telling the machine tool what to do in response to the data it's seeing, and that's it. It doesn't have to store the data, really. It just has to open that stream and keep that connection where it's seeing what's going on with that peripheral. It's still a client application. It just has a much simpler job than these client applications that develop OEE metrics and things like that. Anyone else? Okay. Who's next? There he is.